question which appeared in today's contest. Actually, we have given a number of vertices in our test cases, and on each test case there's a monkey which can either move anti-clockwise or clockwise. Means, like for example, there's a monkey over here and there are monkeys over other vertices. Okay, he can move anti-clockwise as well as clockwise. Whenever he moves from his position and goes on to some other vertex, there's a collision. So we have to count all the number of ways that are possible so that at least one collision happens. Okay, so how we will do this question? I just found a similar relation when I was going through the test cases. Like for example, when the number is 3, the answer is 6. Okay, and when the number is 4, the answer is 16, I guess. Oh, okay, 14. And when the number is 5, the answer is 30. You can write and you can calculate all the number of ways for 5 in your copies. And when n is 6, it will be very time taking if I do it in the video, so I won't be doing it. And for 6 it is 62. So you can clearly see the test cases follow the relation, or you can say function 2 to the power of, we can say 2 to the power of n minus 2. Okay, so this would be our answer. We just have to calculate this, but we know that the test cases can be pretty huge, so we have to return it by the modulo 10 to the power 9 plus 7. Okay, so we will be doing, like, first we will be declaring our answer variable that would be in the type of long. I have already shortened its name by using the property, or you can say macros type def. Okay, I am initialized it to 1, and I will take a mod. 10 to the power 9 plus 7 can be written as this. 1e9, if you write it, it's similar to 10 to the power 9. Okay, instead of writing so many zeros, you can directly write it like this way. And one more variable I will be using modular exponentiation to calculate the power instead of using inbuilt power function. Okay, because it reduces the time complexity. It just takes logarithmic time, so that's why. So while my number is big, I will just use that formula. That's pretty much easy. If it's odd, if the number is odd, it kind of adds, it kind of multiplies with the power you have calculated till now. This x will be calculating my the power in the terms of 2. Okay, and every time, in every iteration, we will reduce a number by 2 and we will increase the power by 2. Okay, increase the power by 2, reduce the power by 2, and if the number is odd, multiply it with your answer. Reduce the number, or you can say divide the number by 2. And increase the power by 2. This is the modular exponentiation, and in the end I just want to return my answer, and that would be stored by answer variable answer minus 2. Okay, and I just have to now apply my modulus properties, and so that there's no integer overflow error. Okay, and wherever we are multiplying, I will just add percentage mod, because test cases can be pretty much huge. I will run the code. Answer into x. Okay, we have not taken the variable x is 2. Okay, because you can clearly see the function 2 to the power n. So that's why we are, every time we will be increasing our power by 2. Increase the power by 2. As I was saying, like if I show you 5, 6, 7, you can clearly see the relation of the answer. See, expected answer is the same of what we have actually got here, 2 to the power n minus 2, and we'll just submit it and you can see it's accepted. So thank you guys, that's all. Hope you have understood. We can also calculate the power using a for loop, but that would actually result in time limit exceeded for some test cases. You can, instead of this, you can just use a for loop and multiply your power every time you go through that loop by 2. This is the shorter version of calculating power of something for n number of times. So you can use this. It will be pretty helpful in competitive programming. Okay, thank you guys.